The Rd-03D mmWave human detection sensor by AI Thinker is truly amazing. This small and affordable millimeter wave radar sensor can do things that even expensive high-end human detection sensors cannot. Personally, I believe this millimeter wave sensor will soon replace most human detection sensors. That's because with this sensor, you can not only detect humans but also measure their distance accurately. And it's not just about one target. This millimeter wave sensor can detect up to 3 targets at the same time and measure their distances with great accuracy. And the best part is you have full control over to choose whether you want to use this sensor for detecting a single target or multiple targets. If you want to detect just one target, you can use the single target detection command. And if you want to detect up to 3 targets, you can use the multi-target detection command. This sensor doesn't just stop there. It can also measure the angle of moving targets in addition to detecting them and calculating their distances. This capability opens up a whole new world of possibilities for advanced tracking systems. For example, it can be used to intelligently recognize and track how a person moves within an area. It can follow the path of their movement, understand where they are heading, and keep track of their position over time. This makes it highly useful for monitoring human activity and identifying motion patterns. Another impressive feature is its ability to calculate the speed of a moving human by analyzing motion data. In security projects, this mmWave radar sensor is a game changer. It can not only detect intruders but also track their movements within the protected area in real time. You can set it up to trigger alarms, activate cameras, or even send notifications when unauthorized movement is detected. Its ability to monitor multiple targets simultaneously ensures no movement goes unnoticed, making it perfect for advanced surveillance systems. Compared to a traditional PIR passive infrared sensor, the Rd-03D millimeter wave human detection sensor is in a completely different league. While a PIR sensor can only detect motion and struggles with accuracy in distance or direction, the mmWave sensor goes far beyond. It can measure the precise distance, angle, and even speed of moving targets, something a PIR sensor simply cannot do. Plus, it can track multiple targets at the same time, while a PIR sensor is limited to detecting general motion in its field of view and can only be used indoors. This makes the mmWave sensor a far more versatile and reliable choice for advanced automation and security systems. Because the mmWave sensor is not affected by light, you can use it both outdoors and indoors. Now, my question is, will you still use a PIR sensor? Let me know in the comments. Today, we are going to use this powerful mmWave radar sensor with ESP32, and let me tell you the information and data I'm going to share with you. You cannot find it anywhere else because until today, no one has used this sensor with Arduino, ESP32 or ESP8266. So don't waste your time looking for its Arduino library. Just sit back, relax and watch this video. We will practically detect single and multiple targets, and based on the measured distance and direction of movement, we will control a specific load. So without any further delay, let's get started. The Rd-03D is a radar module made by Sensor and AI Thinker Technology Company Limited using the Artificial Internet of Things AIoT S5KM312CL chip from IC Legend. It is a millimeter wave sensor SoC system on a chip based on frequency modulated continuous wave FMCW radar transceiver technology. It works in the 24 GHz K band with a maximum sweep bandwidth of 0.25 GHz. This module uses FMCW waveform and advanced signal processing technology combined with built-in intelligent positioning and tracking algorithm to detect multiple targets in a specific area. It can intelligently distinguish the human body in the form of movement, micro-movement, and rest. The module has good resistance to external interference and is not affected by wireless signals such as Wi-Fi. Some of its key characteristics are: it supports 24 GHz ISM frequency band, features a high-performance microstrip antenna with 1 transmitter and 2 receiver, offers accurate target tracking and positioning. Maximum sensing distance is 8 meters. The range resolution is 0.75 meters and the ranging accuracy is 0.15 meters. Detection range covers plus minus 60 degrees horizontally and plus minus 30 degrees vertically. Supports UART communication, enabling easy adjustment of radar settings via the serial port. Operates on a single 5-volt power supply, suitable for wall mounting. Typical application scenarios are smart home appliances, intelligent business, smart security, and smart lighting. The Rd-03D model comes with a standard socket connector and features an onboard PCB antenna. It operates in the frequency range of 24 to 24.25 GHz. The module is designed to work in temperatures ranging from minus 40 degrees Celsius to 85 degrees Celsius and can be stored at temperatures between minus 40 degrees Celsius and 125 degrees Celsius with less than 90% relative humidity. It requires a 5-volt power supply with a current of at least 200 milliamps. The model uses a UART interface with a default data rate of 256,000 bps. For the precise human detection, distance measurement, direction of movement, and speed measurement, it should be installed 1.5 to 2 meters above the floor. The radar installation azimuth is shown in figures A or B. Positive and negative directions are azimuth angles, up and down directions are pitch angles, and the radar antenna plane normal direction is 0 degree. The range for detecting moving humans covers plus minus 60 degrees horizontally and plus minus 30 degrees vertically. The maximum detection distance in the normal direction is 8 meters. On the back side, you can see that it has a standard socket connector which allows us to easily connect it to any controller board without soldering any wires. Unfortunately, they forgot to send the connector, so now I will have to solder the wires to the RX, TX, ground and 5-volt contacts. We are going to use only 4 wires to connect this sensor to the ESP32. And let me tell you, the operating range of TX and RX pins is 0 to 3.3 volts, so you can safely use this radar module with 3.3 volt compatible controller boards. Let me solder the wires and then I will explain how to connect it to the ESP32 Wi-Fi plus Bluetooth module. All the 4 wires have been soldered and now I can use these 4 wires to connect it to the ESP32. For the connections, you can follow this circuit diagram. I'm using serial port 1 on the ESP32. I performed my initial experiments on a breadboard, but since I also need to control a load automatically, I realized I would need a relay for that. So I decided to create my own ESP32 based development board using Altium Designer. On this board, I added a 5V 3A power supply and a 5V SPDT type relay. After designing the PCB and generating Gerber files, I opened the All PCB official website. To order, click on PCB code, click on Upload Files. Select your Gerber files in a zip folder and click Open. The system will automatically find the number of layers and the dimensions. Choose the number of PCBs you want to order. You can leave everything else as it is, or you can change the settings if you want. Next, select your country and click Quote Now. To save more money, you can change the shipping service. When you are happy with the price, click on Add to Cart. After a few days, I got this from the All PCB, so let's go ahead and open up this box. I got 5 high-quality PCBs and I'm really thankful to All PCB for sponsoring such high-quality PCBs. The traces are clean and precise and the silk screen is clear and easy to read. It's impressive how well they have managed to capture the detailed design. I've already made a quite detailed video on SMD soldering. In that video, I have explained everything from the tools, how to place components on PCBs, and how to use an SMD rework station to solder those components. After watching that video, you will become an expert in SMD soldering. We are done with the soldering of all the SMD and through-hole components and it looks good. For only $5, you can get single or double-sided PCBs up to 150 by 100 mm in size. This is great because most companies only offer sizes up to 100 by 100 mm. With All PCBs 150 by 100 mm size, you can make multiple PCBs on one board, saving money by paying just $5. So, what are you waiting for? Click on the first link in the description below. When I reached this point, I got stuck for a while. That's because no one had used the RD-03D mmWave sensor with Arduino, ESP32, ESP8266 or Raspberry Pi Pico before. I couldn't find any Arduino library for this sensor, not on the product's official page and not by searching in the Arduino IDE library manager. So as always, I decided to write my own code. What I'm about to explain is something you need to listen to carefully and understand because it's not guaranteed that you will always find a ready-made library for every sensor you work with. Sometimes you will come across sensors that don't have a library available anywhere. That's when this knowledge will really help you. So let me explain how I tackle this. I started off by downloading all the PDF files from the AI Thinker products official page. In the datasheet, I went to the communication protocol section where I confirmed the default baud rate of the Radar serial port, which is 256,000 bps. I also carefully studied the data frame format, including information about the frame header, intra-frame data, and frame tail, and closely observed how the radar outputs the detected target information, including X and Y coordinates, target speed, and distance value. This is an example of the data that the RD-03D radar sends when it detects a target. Now, this data might look complicated, but it's just a set of numbers that tell us what the radar is seeing. Here's what the radar is saying. It found one target, which we are calling target 1. That's the blue part in the example. For target 2 and target 3, red and black, the radar didn't detect anything, so their data is all zeros. Now, let's see what information we can get about target 1. Target 1 X coordinate. The X coordinate tells us how far left or right the target is. The radar gives the value as 0x0e plus 0x03 multiplied by 256. We multiply by 256 because the data is stored in 2 bytes for each value. Lower byte is 0x0e 14 in decimal. Higher byte is 0x03 3 in decimal. To get the full X coordinate, value is equal to 3 multiplied by 256 plus 14, which is equal to 782. Since it's 0 minus 782, the result is minus 782 millimeter, which means it's 782 millimeter to the left. Target 1 Y coordinate. The Y coordinate tells us how far forward or backward the target is. The radar gives 0xb1 plus 0x86 multiplied by 256, which equals 34,481. But because the radar uses a specific format, we subtract 2 raised to the power 15 or 32,768 and we get 1,713 millimeter. So the target is 1,713 millimeter forward. Target 1 speed. This is how fast the target is moving. The radar gives 0x10 plus 0x00 multiplied by 256, which equals 16. Since it's 0 minus 16, the speed is minus 16 cm per second. A negative value just means the target is moving backward. Target 1 distance resolution. This tells us how precisely the radar measured the distance. The radar gives 0x68 plus 0x01 multiplied by 256, which equals 360 millimeter. Next, using the X and Y coordinate values, we can find the target distance and angle. I will explain this in the programming. So this is how we take the raw data and turn it into useful information. I wrote a simple program to check the data coming from the radar. As I already explained, the RD-03D radar module can detect either one target or multiple targets. If you want to activate single target detection, you just need to send the single target detection command to the radar. And if you want to switch to detecting multiple targets, you send the multi-target detection command instead. Right now, as you can see, I have implemented the single target detection command to test how it works. This code listens for data coming from the radar sensor through serial 1 and stores it in a buffer called RxBuff. It checks each piece of data and adds it to the buffer, keeping track of how much data has been collected using RxCount. To prevent the buffer from overflowing, it stops adding data if it reaches the buffer's maximum size. The code also looks for a specific pattern 0x55 followed by 0xCC at the end of the buffer to confirm that a full message has been received. Once a complete message is detected, it calls the process radar data function to handle the data. There is also a print buffer function that can display the collected data in a readable format for debugging purposes. I have already uploaded the code. Now, you need to be mindful of the radar's orientation when setting it up. There are two ways to install the sensor, and in my case, I'm going with option B. Just make sure the AI Thinker logo is at the top. As you can see, we have successfully read the complete data from the radar. Right now, it's only detecting one target, so the data for the other two targets shows as 0. You can see how responsive the radar is. I've already explained this data frame in detail, so I'm sure there is no confusion at this point. Next, I activated the multi-target detection mode and the radar successfully detected 2 targets. You can find the complete code for detecting multiple targets on my website electronicclinic.com. For now, I'm going to focus on single target detection because right now I'm alone in my studio and honestly I don't even need to detect multiple targets because my work can easily be done with single target detection. That's because I'm mainly interested in the target's distance and angle. Looking at this data, it's hard to understand what's going on. That's because all the values are in hexadecimal format. So let's first convert this data into a format that's easy for humans to read and understand. So as you can see, I have made a few changes to the previous code. This time I have also defined some variables specifically for the target, which will help us work with the data more easily. This code extracts and calculates information about a target from a data buffer or XBUF. It combines 2 bytes to get the x and y coordinates, then adjust them. The x coordinate is shifted by 0x200 to center it around 0, and the y coordinate is shifted by 0x8000 to handle negative values. The speed is calculated similarly, adjusted by 0x10 for an offset. The distance resolution is read as is, while the total distance is found using the Pythagorean theorem to combine x and y. Finally, the angle is calculated using this function, converting the position into degrees for easier interpretation. Finally, using these instructions, we send data to a serial monitor. Now, you can easily see the distance, angle, and other data. It might look a bit overwhelming because I'm sending a lot of data to the serial monitor. I did this just to show you that everything is working perfectly, but let's simplify it by not printing the x-axis, y-axis, speed, and distance resolution. Now, it's looking much cleaner and easier to understand. Focus on the distance and angle because this test will give us a full picture of the radar's capabilities. Honestly, this radar isn't just responsive, it's impressively accurate. I've personally tested it and it can measure distances up to 8 meters with precision while also calculating the angle accurately. What really stands out is how reliably it measures angles. With this angle information, the possibilities are endless. For instance, you can use it to control loads in different directions based on a target's left or right movement. Imagine automating lights, fans, or other devices just by moving in a specific direction. To explain this, I'm going to use this 5-volt SPDT type relay to control this 110 or 220 volt AC bulb. This relay is connected to the ESP32 GPIO13. For the relay connections, you can follow this circuit diagram. Remember safety first. When the 110 or 220 volt AC supply is connected, never touch the relay contacts as it can be extremely dangerous. It is important to note that when working with mains voltage, proper safety precautions should always be taken, and it is advisable to consult relevant electrical codes and standards. I modified this code slightly to aid relay control based on the radar's target detection. Most of the code remains the same, but here's what I added. First, I defined the relay pin relay equals 13 and a flag relay flag to track whether the relay is on or off. The flag helps prevent unnecessary toggling of the relay. I also introduced 2 timers, relay on timer and relay off timer, to handle delays for turning the relay on or off. These timers ensure that the relay only activates after a target stays in range for 2 seconds and deactivates 5 seconds after the target moves out of range. This avoids false triggering caused by momentary detection glitches. Here's how it works. When the target is within the set distance range, the code starts the relay on timer. If the target stays in range for 2 seconds, the relay turns on and the relay flag updates to indicate the relay is active. Similarly, if the target moves out of range when the distance is greater than 280 centimeter, the relay off timer starts. After 5 seconds, the relay turns off and the flag resets. The timers are reset if the target isn't consistently in or out of range, ensuring smooth and accurate control. This setup keeps the system responsive and reliable for load control. Let's watch this in action. As you can see, the bulb is on because my distance from the radar is within the set limit. The light will stay on as long as I'm in this area. The radar's algorithm is so smart that even if you're not moving, it can still detect you. This means it can sense even very small movements called micro movements. Some sensors fail to detect a person when they are completely still, but that's not the case with the Rd-03D mmWave radar. It can intelligently pick up even the tiniest movements. For example, I have been in this area for a while and the bulb hasn't turned off even once, nor has there been any false triggering. I also tested this while sitting completely still on a chair and the sensor worked perfectly. As I mentioned, the bulb will stay on as long as I'm in this area, whether I move forward, backward, left or right, as long as my distance is within the set limit. The bulb will only turn off when my distance increases and I leave the area. For example, if I go to another room, the light will turn off automatically. As you saw, the light just turned off. Now it will stay off until I return to this room. This feature makes it perfect for automating loads in bathrooms, staircases, lawns, and even for security purposes. You can confidently use this radar for both indoors and outdoors. Now let's control the load based on the target's angle. I again modified the code and this time the relay turns on when the angle is between 60 and 95 degrees and turns off when the target's angle moves out of this range. Let's watch this in action. This time the light will stay on as long as I'm in this area. The light will only turn off if I move towards the bathroom or go to the other side of the table. For this demonstration, I'm using a single bulb, but you can use multiple bulbs too. For example, when you are in the center of the area, one light can turn on. When you move to the left side, another light can turn on, and when you move to the right side, a different light can turn on. You can even control a ceiling fan or control the direction of lights on a staircase based on the target's movement. I will also make another video about controlling strip lights and servos based on human position or angle. Consider subscribing if you don't want to miss that video. So that's all for now. Support me on Patreon for more videos. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.